And I know you are dying to know, what makes part 2 different than part 1? Well, what we're going to do is we're actually going to apply that idea of simplifying a square root. And we're going to do that by moving on to this theorem called the Pythagorean theorem. And if you don't know how to spell it, just look up above. Now, a theorem in math is just kind of like a rule. And this rule, the Pythagorean theorem, we can only use it if we have something called a right triangle. Now, if we were in class together, I would ask, does anybody know what a right triangle is? And hopefully somebody would be able to tell me that a right triangle simply means that it's a triangle that has a 90-degree angle on it. Okay, so it says, here's a couple pictures of a right triangle. Notice they all have a right angle, which means 90 degrees. They have a right angle, which means 90 degrees. All right, something you're going to notice different probably from me and Miss Burley is that I have a left hand and it's going to get in your way a few times. So just make sure you listen because I promise I am quite a talker, so you will be able to hear it. So the big idea is there are always two legs in a right triangle, L-E-G-S. There are two legs and one hypotenuse. Two legs and one hypotenuse. The hypotenuse is always the longest side. Whoopsie. I almost wrote longest instead of longest. Sometimes students call it the slanted side. And then there's the legs. The legs, notice how I use a capital L? The legs are the two sides that make the right angle. In other words, they're the two sides that make the L. Okay, they're the two sides that come together to make the right angle. Well, they look like an L, which is very convenient because leg starts with L. Some students call those the straight sides. Can you point out the hypotenuse and the legs of the following triangles? Well, I would suggest going and finding the hypotenuse first. The hypotenuse is kind of the slanted side. So the first thing I notice is that this one, that's the hypotenuse because it's slanted. Here's the hypotenuse on this one. It's slanted. And this one's kind of distorted, but this is the hypotenuse. If you kind of turn the triangle around, you would notice that's the slanted side. If you don't like using the word the slanted side, it's definitely the longest side. And if you don't like that, it's the side away, furthest away from the right angle as possible. That makes the other sides legs. So if I'm writing too fast, go ahead and pause the video. But that makes these sides of the triangles the legs of the triangles. So two legs and a hypotenuse. My husband is rubbing his leg because I just said leg. True story. Okay, the formula for the Pythagorean theorem is, and I know you know this from middle school, a squared plus b squared equals c squared. A and b, these will become numbers, and they are the legs of the triangle. C is the hypotenuse of the triangle. You will be given two sides. Now, I'm not saying you're going to be given the two legs. I'm just saying you're going to be given 2 out of 3 of those. Maybe I'm going to give you A and C, or maybe I'm going to give you B and C, or maybe I'm going to give you A and B. And you will have to find the missing third side by using that equation. So let's take a look at this particular example. I have it pretty filled in for you. In this one, notice we're missing the hypotenuse. We're missing C because we have A and B. And if you're like, Miss Langella, I thought that was A and that was B, that's okay. As long as you know the legs are A and B, and you know the slanted or the longest side is C, these two can be switched up, A and B, but C has to be the longest side. So we're missing C. So if I say, okay, oh look, I even switched that, didn't I? I said, in my formula, look, I made A 8 and I made B 6, and that's totally fine. So I have A squared, B squared, C squared. I have A is 8, I have B is 6, and I have C is, I don't know. So take away that A. If I could teach in a hologram, I would pick this A up, I would throw it away, and I would replace it with 8. So I have 8 squared instead of A squared. And I'd pick this B up, I'd throw it away, and I would replace it with a 6, so I have 6 squared. And then, well, I don't have any to throw that C away with, so it has to stay C squared. Now I evaluate. 8 squared is 64. 6 squared is 36. add those together. 64 plus 36 on your calculator is 100. And now you're going to take the square root of 100. And if you don't know the square root of 100, you can use your sheet or your calculator. The square root of 100 is 10. So the value of C is 10. Now the trick comes in that it's not always going to be a perfect square root, but we'll deal with that from what we learned last section. So in this one, we definitely have A. See how we have one of the flat sides? We don't have this flat side, B, but we do have the slanted side, C. So in this one, we're going to say we're missing B. So A is 4, B is, I don't know, and C is 5. So A squared, B squared, C squared. Take away A, throw it away, replace it with that 4, 4 squared. Take that B, throw it away. Oh, whoops, we can't, can we? So leave it B squared. Take that C, throw it away, replace it with the 5, 5 squared. And now use your calculator if you don't know. 4 squared is 16. 5 squared is 25. And, now how do I get this B by itself? Well, I know Miss Burley did solve for a letter. And 25 minus 16, when we move it to the other side, we practiced that last chapter, is 9. So we have B squared equals 9. And like we get so excited, we're like, we're done, but we're not done because B is not by itself. So to undo a square, you take the square root of 9. And if you don't know, you can use your chart, you can use your calculator. The square root of 9 is 3. So the missing side is 3. Now what we're going to do is we're going to go ahead and solve these particular problems. Excuse me. So definitely I have a right triangle. Here's the right angle. And it says find the missing side. Answer as a decimal if needed. Ooh, that's kind of nice to answer a decimal if needed. I like that. All right, so let's write A squared plus B squared equals C squared. And go to your picture. Identify C if you can. Here's C. Identify A if you can. Here's A. Identify B if you can. Here's B. And you can flip-flop A and B. So I'm going to take this A away and I'm going to make it a 24. I can't take the B away because I don't know what B is. Take the C away, make it 40. Now, we can use our calculator to do 24 squared, 576. Drag down that B squared. And use your calculator for 40 squared, 1600. How do I move this 576 over? Answer is minus or subtract. All right, B squared equals 1024, and that's definitely not the answer, right? Like that does not fit in with 24 and 40. Because what did we forget to do? Forgot to take the square root, 32. And everything is in meters, so this must be in meters as well. Number 8. Find the length of the roof. That should definitely say roof, not room. That's kind of cute. Find the length of the roof beam. Answer as a decimal if needed. Now, I don't know about you guys, but I certainly hope that the beams in my attic are like they fit the Pythagorean theorem. Because if not, I mean, if that beam is a little bit short, we are not going to build a house that's perpendicular, and we're going to have a lot of cracking and foundation issues. So let's go ahead and make sure that we have a safe house. So the slanted side is the roof. I'm going to make that my C. Always do the slanted side as C. And then it doesn't matter if you do A and B like I did, or if you do B and A. Like I just made my A 5 and my B 1.3. You can switch those, but the roof beam has to be C. So A squared plus B squared equals C squared. If I could, with a hologram, I would take this A away that my finger's on, I would throw it away, and I would replace it with the number 5.
I wish you were Tony Stark.
My husband just says, I wish I was Tony Stark, and I do. No, then I couldn't marry you, honey. Okay. Then I would take this B, I would pick this B up, I'd throw it away, and I'm going to make it 1.3. And then I don't know C, C squared. Grab my calculator. So 5 squared I know by heart is 25. 1.3 squared is not something like we all might know by heart. 1.3 squared is 1.69. Hey Nate, can I have my computer charger, please? Equals C squared. It's over by the couch. Thank you. Now these two do not need to move to a different side. They just have to get put together because they're already on the same side of the equal sign. So 2669. Now, it says answer with a decimal if needed. Well, good. Then we don't even need to do that whole thing we did last section. I'm going to take the square root of the answer I just got, 5.17 when we round. 5.17, and we are in meters for C, not for C squared. And that's our answer. All right, let's move on to the next page. It's always a fun time learning. I know you're enjoying this. Number 9. Thank you. An anchor line for a tower needs to be replaced. The tower is 96 feet tall. The anchor line is 105 feet long. How far from the tower can it be placed? Well, that again is a very important thing if you don't want things to lean or fall. The right triangle is one of the most important things ever to me. I'm going to put a squared plus b squared equals c squared up top so we don't forget it. All right, and I'm going to identify C if I can. That's the slanted side, or the side away from the right angle, so it's the anchor line. A and B can be switched around. Those do not matter. So a squared plus b squared equals c squared. Let's do this. I'm going to take away a and replace it with 96. Don't forget to square it. I can't take away b because I don't know it. I'm going to take away c, replace it with 105, and square it. And now, get my handy dandy. 96 squared is a large number. 105 squared is even bigger. Oh, those are big numbers. I gotta take this to the other side to get b by itself. Type it in my calculator. Okay, that's a big number, but we are going to be just fine. I know you're worried. All right, so b squared equals, what do I have, 1809? I take the square root. Now look at the directions. I want it in radical form, and I also want it in decimal form. Let's do the decimal form easier because, to be honest with you, that's going to be easier. So there it is as a decimal. I get 42.53. Put that right here, 42.53, and that's to the nearest hundredth. And we're in feet. 2 decimal places is hundredth. Now we got to do like the square root thing. So to do the radical, that's what radical means. Radical means like leave it as a square root like you did yesterday with those problems. So we need to think about the square root of 1809. And we need to use this chart. Where's my chart? Here it is. This chart here. We had to figure out which one of these numbers in the boxes, which perfect square goes into 1809. That's my husband. Happy birthday. Happy birthday, Troy. The head dog hair on it. Happy birthday. We'll just leave that there. And you conveniently had to put it in the right spot because he's right. It's not in these 2 columns. Dun, 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 dun. Okay, so here, he just eliminated 1,000 options for you. So we're going to do 1809 divided by 100. No. 1809 divided by 81. No. 1809 divided by 64. Boo. 1809 divided by 49. Boo. 1809 divided by 36. Boo. 1809 divided by 25. Boo. 1809 divided by 16. Boo. 1809 divided by 9. Ding, 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 ding. 9 times 201. See, aren't you glad he came along? So I'm going to change this to a 9 times 201. And the reason we do that is because we know the square root of 9. Notice I didn't write the bigger number first. I wrote the perfect square first. The square root of 9 is 3. And the square root of 201 is, well, an icky number. So 3 squared to 201 is my answer. And we're in feet. And I know all of you are dying to know, I wonder if that's right. I wonder if I did that correct. Let me show you. If you do 3 square roots of 201, boom, you get the same decimal as if you did 1809. So you know that you're right, which is fantastic. Number 10. Oh, look at this. We're missing the slanted side, so we must be missing C. Here's A, here's B. You're more than welcome to pause the video and try it yourself, or just kind of hang out with me. A squared plus B squared equals C squared. Take away A, throw it away, replace it with 7 squared. Take away B, throw it away, replace it with 3. Take away C, oh poop, we can't take away C. So we're solving for C. Now some of you might be like, hey, can't I replace C with X? Surely you can if you want to. If you want to take C away and replace it with X, by all means, go ahead. You are solving for X after all. So you know what? Let's do it. Let's replace C with X because that is technically what we're solving for. Ooh, there's not going to be any moving on this one because they're on the same side. We just have to change 7 squared to 49, 3 squared to 9, and add those together. So we're going to have 49 plus 9 equals X squared. Then we're going to add those to get 58 equals X squared. And then it says, look at these, look, we got to do radical form and nearest hundredth. So let's do the decimal one easier first because it's easier. So we're going to do square root. Answer 7.62. And there's no units because it's not a word problem. And that is always the easier one. Now we're going to do this radical form thing. So we have to think about the square root of 58. And we got to get this list. 58 is a pretty small number compared to 1809. So I know I can start at 49 and work my way up. So I have to do 58 divided by 49. If I get a decimal, it's no-go. Bummer. 58 divided by 36, no-go. 58 divided by 25, no-go. 58 divided by 16, oh, maybe this is the ticket. No. 58 divided by 9, oh, it's so exciting. No. 58 divided by 4, no. 58 divided by 1, well, I could divide by 1 all day, so it is useless. So oddly enough, I'm going to write there is no perfect square in 58. Oh no. So I know you are dying to know, what do we do when that happens? Just write square root of 58 as your answer. Okay? Otherwise, you'd have to do what we did in the last problem. Number 11. How are we doing? Oh, good. We only got 2 more. You guys are doing fantastic. I'm very proud of you. Oh, where is the slanted side on number 11? Dun, 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 dun. Am I making you dizzy? Okay. Where is the slanted side in number 11, you might ask? Well, kind of tilt your head, make the L shape. Which one's not part of the L? Aha! The 10 is the slanted side. We can make this A and this B, or vice versa. It doesn't matter. Solve for the missing side. A squared plus B squared equals C squared. Take away A, throw it away. What does A get replaced with? X. Take away B, throw it away. What does it get replaced with? 6. Take away C, throw it away. What does it get replaced with? 10. I'm a lot to handle. I recognize that, just so you know. Okay. Drop down that X squared. 6 squared is 36. 10 squared is 100. If you don't trust me, use your calculator or just the chart. That 36 is on the wrong side to get X by itself, but don't worry. My super math teacher skills know to subtract 36. X squared equals, because those go 100 minus 36. You can use a calculator. You should check me. 64. I'm right. 64 does not fit those two numbers. I can't tell you how many times kids get this far and they don't take the square root. And I go, oh. But like, see how like 64 wouldn't make sense with such small numbers like 6 and 10. Aha! It's because we forgot to do the square root. Square root of 64 is 8. Oh my goodness. So it doesn't even have a decimal. It's just 8. So you might be like, okay, Miss Langeli, how do I simplify that? Well, remember our magic trick? If it's already on your sheet, then the answer is just 8. There is no square root when it's perfect. So I'm going to write perfect with a smiley face because smiles make everything better. Number 12. Can these 3 things, different type of question, can they form a right triangle? The most important thing that I need you to recognize is, on these ones, you're just going to say yes or no. And you might be like, oh, I'm just going to guess no and yes and no and yes. Okay, don't do that. because I promise these will probably be the easiest ones you do. All you need to identify is C. C is always the most important one. And how do you identify C? C is the biggest one. So I'm going to go through and I'm going to circle 39 because it's the biggest and put a C by it. I'm going to circle 61. I'm going to put a C by it because it's the biggest. And then I'm going to circle 38 and put a C by it because it's the biggest. And now I'm going to go through and solve each problem. So I'm going to do a squared plus b squared equals c squared. I don't care which one's a and which one's b. I'll do a and b. So I do 15 squared plus 36 squared equals 39 squared. I'll hop on right here and ready? 15 squared, 36 squared, 39 squared. Okay, you ready? So 15 squared is 225. 36 squared is 1296. 39 squared is 1521. And I'm going to add these and see if it equals this. So 225 in my calculator plus 1296 in my calculator. And yay! 1521 does equal 1521. So is this a right triangle? Yippee skippy, it sure is. Yes. With an exclamation, 2 exclamation points and a smiley face because that makes it better. All right, part B. I'm trying to find a good spot for that calculator in my left hand. And I think that's the trick right there. So A and B, and we already identified C. C's always the longest side. So I'll do 60 squared for A. I'll do 12 squared for B equals 61 squared for C. And 60 squared, 12 squared, whoopsie, and 61 squared. All right, so I have 3,600 there, 144 there, 3721 there. Add these two together, 3744, 3721. Are those the same? Because I just drug that down in case you're wondering. No, these are not a right triangle. So sad face. You don't have to do the sad and happy face. It just, makes it better. Because we all love math so much. Okay, part C. So here's A, here's B. Again, A and B can be switched. So A squared, 35 squared. Plus B squared, 13 squared. Do you hear my child screaming in the back? Equals C squared, 38 squared. Let's see, does it? Oh, I'm so excited. 35 squared, 13 squared, 38 squared. Oh, I hope I get a yes. Let's check it out. So this is 1, 2, 2, 5. 13 squared is 169. 38 squared is 1444. And now all we do is put these two together. Oh, boo. So I get 1394, and I'm saying boo because that doesn't equal 1444. So do these three make a right triangle? No. That is the end of Chapter 10, Section 1, Part 2, Pythagorean Theorem. Have a lovely day.